So welcome to the next session, my dear students. So in the previous session we have completed all the theory part of quality characteristics of water, and now in this lecture we are going to do all the previous GATE examination questions. Okay, so let us start the questions part. Two point two as per your worksheet. 2.2 quality parameters of water. Quality parameters of water. Let us start with the first question. It is a theoretical question. Most of the turbidity meters work on the scattering principle. The turbidity value so obtained is expressed in. Question number 1, GATE 2004, 1 mark. The question is the turbid meters works on light scattering principle. Light scattering principle value obtained is expressed in. Okay, the turbidity meters works on the light scattering principle value expressed in. See here, so there are two kinds of turbid meters. So one is light absorption technique, which works on light absorption technique, such as Jackson turbid meter and Jackson turbidity rod, and Bale's turbid meter. So all these three will have units of silica turbidity unit. So all these three, the unit is STU or JTU. Okay, so the unit is silica turbidity unit, or simply turbidity unit is a unit when it is working on light absorption principle. If it is working on light scattering principle, so using light scattering principle, which equipment works? Nephelometer. Nephelometer is the only equipment generally which we use for water supply. Okay, that is it is said that mostly used. So mostly we use nephelometer for water supply. So that is here the unit for light scattering principle is NTU, Nephelo turbidity unit, or Formazin turbidity unit, FTU or NTU. Both are correct. If both are present, preferably it is NTU, because as per Indian Standard Code IS 10500 2012, it was given as NTU only. Okay, so if NTU is present, this is the first option we need to choose. So if NTU is not present, then FTU can be chosen, but NTU is present here, so NTU is the answer. NTU, Nephelo turbidity unit, is the answer. Okay, so next question. Question number 2, GATE 2005, 1 mark. Question number 2. Again, this is also theory question. Question number 2, 2005, 1 mark. So here 1 TCU is equivalent to the color produced by. So 1 TCU means what? 1 TCU means true color unit. 1 true color unit is defined as 1 milligram of platinum as chloroplatinate ion mixed in 1 liter of distilled water. 1 liter of distilled water, that is nothing but 1 true color unit. That is nothing but 1 true color unit. So true color unit, it is nothing but, so 1 milligram of platinum as chloroplatinate ion is mixed in 1 liter of distilled water. Okay, so that is 1 TCU. It is 1 TCU. That is the question number 2. So let us discuss question number 3. Question number 3, GATE 1991, 1 mark. Question number 3, 1991, 1 mark question. So the pH of water admitted into a treatment plant, pH of water admitted into a treatment plant was 6 in the morning. Consequent to the inflow of raw water from a different source, it changed to 8 in the next 24 hours. Assuming linear variation in the time of hydrogen ion concentration, the time mean pH value of the water over this 24-hour period is. So here what is the given data? Initial pH is 6.0. After 24 hours, the pH entered is 8.0. Okay, so after 24 hours, it has become 8.0. So he is asking what is the mean pH over this period. What is the mean pH over this period? So here we need to find the average hydrogen ion concentration. So this is first initial pH. So what is the initial H plus ion concentration? Initial H plus ion concentration. So if you take this is a time, okay, so initial pH is 6.0 and the final at a 0, and this is 24 hours. This is 8.0. Now he is asking mean. Mean means what? This at this location somewhere here. Mean is not average of 8 plus 6 by 2. Mean is hydrogen concentrations mean we need to find. So the hydrogen plus ion concentration is 10 to the power of minus 6 mole per liter. Similarly here the hydrogen ion concentration. So this is initial. So H plus ion concentration final 10 to the power of minus 8 mole per liter. So it is linearly varying, that means average H plus ion concentration, is equal to 10 to the power of minus 6 plus 10 to the power of minus 8 by 2. So if you do this, you will get it as 5.05 into 10 to the power of minus 7, 5.05 10 to the power of minus 7 mole per liter. This is hydrogen plus ion concentration average value. Now pH, mean pH is equal to minus log of H plus ion concentrations average, which is equal to minus log of 5.05 into 10 to the power of minus 7. Okay, if you do this, you will get the mean pH, which is equal to 6.296. Okay, 6.296, that is the answer. 6.296 is the answer. Okay. So that is question number 3. Question number 3. Let us go to the next question. Question number 4. Question number 4, again theory. 1992 1 mark question. 1992. Question number 4, 1992 1 mark question. So methemoglobemia, the blue baby syndrome, is caused by consuming water containing excess of, simple. So methemoglobemia is caused due to consumption of water containing excess nitrates, So it is because of the water which is having more nitrates. When nitrates dosage concentration is more than 45 ppm, then it causes methemoglobemia. Okay, when nitrates more than 45 ppm, then it causes methemoglobemia. Okay, then it causes methemoglobemia. It is 1992 1 mark 4th question. 5th question, again this is also theoretical question. 1992 1 mark again. So 5th question, 1992 1 mark only. Hardness of water is caused by the presence of which of the following in water? So hardness, question number 5. So hardness is caused due to, see the options are like this: chlorides and sulfates. A is chlorides and sulfates. Okay. Option B is calcium and magnesium. Okay. Option C is nitrates and nitrites. So nitrates and nitrites. Option D is sodium and potassium. So obviously sodium potassium is not a multivalent metallic cation. So hardness is caused due to multivalent metallic cations. So hardness is caused due to multivalent metallic cations. So which are cation means positive sign. So this is not positive. So the multivalent means more than one. So these are metals only, but they are not multivalent. They are cations having unit charge. So multivalent means 2 is multi. So multivalent metallic cations, calcium, magnesium or metallic cations. So the answer is calcium, magnesium. So chloride and sulfate, when it forms compound with calcium and magnesium, then only they causes hardness. Simply sodium chloride or sodium sulfate or magnesium, not magnesium sulfate, a sulfate of any other thing may not cause hardness. Only if they form compounds with calcium and magnesium, then only it causes hardness. So hardness is primarily caused due to multivalent metallic cations, not anything else. Okay. So that is answer of the fifth question. 1996, 1 mark. Question number 6, 1996, 1 mark question. So here, this is also theoretical question. Presence of fluoride in water greater than permissible level 1.5 mg per liter crosses. So fluorine greater than 1.5 mg per liter causes, obviously it reacts with the calcium present in teeth as well as bone. If it is more than 5 mg per liter, it also reacts with bone and causes bone fluorosis. And if it is just greater than 1.5, they causes dental fluorosis. They causes dental fluorosis. Okay, they causes dental fluorosis. So this is the answer. A fluorine greater than 1.5 mg per liter, they causes dental fluorosis. Okay. Question number 7. This is GATE 1997, 1 mark. Question number 7, 1997, 1 mark. So the question is like this. Alkalinity of water can be defined correctly in one of the following. See, alkalinity is defined in 2 ways. One is the capability or the ability of neutralizing, hydrogen ion. Hydrogen ion is called alkalinity. It is caused due to negatively charged. It is caused due to negatively charged compounds. So alkalinity is caused because of negatively charged compounds, and alkalinity is defined as the ability of neutralizing hydrogen ion. So let us see the options. It is the measure of ability of water to neutralize oxygen. Option A, wrong. Option B, it is the measure of ability of water to neutralize carbonates. No, carbonates again they are anions. So these are also negatively charged. They cannot neutralize anion. Option C is, it is the presence of ions in water that will neutralize hydrogen ions. It is exactly correct. It is the presence of ions. So the ions which are present is anions, that is negatively charged compounds that are present in water, which will neutralize hydrogen ion. Hydrogen ion is positively charged H plus ion. So this is the right answer. And the fourth option, let us see, it is a measure of ability of water to neutralize hydroxides. Again, hydroxide is OH minus. So OH minus is an anion. These are also anions. So anion cannot neutralize another anion. So that is why option D is also wrong. So option C is the right answer. So let us go to the next question. Excessive fluoride in drinking water causes. Question number 8, 1998. Question number 8, 1998, 1 mark. Question number 8, 1998, 1 mark. Question number 8. So the question is excessive fluoride in drinking water causes. So first option is Alzheimer's disease. Alzheimer's disease, we didn't discuss anything about this disease, so this is not due to fluoride. And option B is mottling of teeth and embrittlement of bones. So that is the thing about dental fluorosis and bone fluorosis. So fluorine greater than 1.5 mg per liter causes dental fluorosis. So this is nothing but mottling of teeth. So this is also called mottling of teeth. Okay, this is nothing but mottling of teeth. And bone fluorosis or skeletal fluorosis. Bone fluorosis or skeletal fluorosis is also called embrittlement of bones. Embrittlement of bones. So this is the bad effect of excess fluorine present in water. Excessive fluorides present in water. Okay. Temporary hardness in water is caused by the presence of, next question, question number 9. Question number 9. Question number 9. Question number 9 is GATE 1999. Question number 9, GATE 1999. 1 mark question. Temporary hardness is caused due to the presence of. See, hardness is caused because of multivalent metallic cations, and majorly the multivalent metallic cations present in water is calcium and magnesium. And this calcium and magnesium, when react with carbonate and bicarbonate, so it causes temporary hardness. This is called temporary hardness. Okay, so carbonate hardness is also called temporary hardness. Carbonate hardness. So calcium, magnesium, option A is bicarbonates. This is bicarbonate. So bicarbonate of calcium and magnesium causes temporary hardness. The first option is correct. Second option is sulfates of calcium and magnesium. Generally, sulfates and chlorides, they form permanent hardness. Permanent hardness. They form permanent hardness. So the sulfates of calcium and magnesium, so it causes permanent hardness, not temporary. And even chlorides is also same. Nitrates does not cause any hardness. So the option A is the right answer. So 9th question, option A is the right answer. Question number 10. 1999, 1 mark again. Question number 10. Question number 10. So 1999, 10 mark. The question is again theoretical, 1 mark. Blue baby disease, methmoglobebia in children is caused due to the presence of. Blue baby disease, that is methmoglobebia, in children is caused to the presence of, already we have discussed. So blue baby disease because of nitrates, excessive nitrates, is due to nitrates when more than 45 ppm. Okay, so this is 10th question. Let us go to the next question. Question number 11. 1999 1 mark question. 1999 1 mark question. Two samples of water A and B have pH values of 4.4 and 6.4 respectively. Then how many times sample A is more acidic than sample B? So here pH of A, what is the given data? pH of A is 4.4 and pH of B is 6.4. So acidity of sample A upon acidity of sample B. Acidity of sample B. So acidity is nothing but concentration. So H plus ion concentration. What is the H plus ion concentration of A upon what is the H plus ion concentration of B? So here for this H plus ion concentration of A is 10 to the power of minus 4.4. For this H plus ion concentration of B is 10 to the power of minus 6.4. Okay, so here the ratio of H plus ion concentrations, then 10 to the power of minus 4.4 by 10 to the power of minus 6.4. That means it is 100. It is equal to 100. So that means sample A is 100 times more acidic. Sample A is 100 times more acidic than sample B. Okay, that is the answer. 100 times is the answer. Question number 12, 2001, 2 marks question. Question number 12. Question number 12, 2001, 2 marks question. The CF2 plus concentration, Mg2 plus concentration of water sample are 160 mg per liter and 40 mg per liter as their ions respectively. The total hardness of the water sample in terms of CaCO3. See, what is the given data? Let us see. The given data is Ca2 plus concentration is 160 mg per liter, 160 mg per liter, and Mg2 plus ion concentration is 40 mg per liter. 40 mg per liter. Total hardness is how much? So total hardness formula in mg per liter as CaCO3. Total hardness in mg per liter as CaCO3 is equal to Ca2 plus into equivalent weight of CaCO3 by equivalent weight of Ca2 plus Mg2 plus multiplied with equivalent weight of CaCO3 by equivalent weight of Mg2 plus. So this is the formula. So total hardness Mg per liter as CaCO3 is equal to Ca2 plus concentration. How much they have given? It is 160. So 160 mg per liter. So equivalent weight of CaCO3 is 50. Equivalent weight of CaCO3 is 50. Equivalent weight of Ca2 plus is 20 plus Mg2 plus concentration is how much? 40. So 40 multiplied with 40 mg per liter multiplied with 50 is the equivalent weight of CaCO3. Equivalent weight of Mg2 plus is 12. So solving this, you will get the answer of total hardness value. So you will get the total hardness value. Let us see what is the value. 566.67 mg per liter. 566.67 mg per liter. So which is approximately equal to 567 mg per liter. So that is the answer. Simple question. So majority of the questions from this topic will be like this only. So directly they will ask either to find total alkalinity or either to find total hardness. Okay. So let us go to the next question. Question number 13. Question number 13. Question number 13, 2002, 1 mark. 2002, 1 mark. So again and again the same kind of concepts will repeat, but the way of asking may change, but the concept behind the question will be the same. So that is why we need to learn the concepts and we have to apply it everywhere. That is the only thing we can do to achieve good marks. So question number 13, 2002, 1 mark question. So again the same question. In natural water, hardness is mainly caused by. So hardness is mainly caused by, mainly, here see, it is asking mainly. Generally hardness is caused by, in general hardness is caused by multivalent metallic cations. So generally hardness is caused by multivalent metallic cations. There are many, but mainly it is caused by Ca2 plus and Mg2 plus. Mainly it is caused by Ca2 plus and Mg2 plus. Okay, that is the answer. Option A is Ca2 plus and Mn. Mn is manganese, Mg is magnesium. So that is wrong. So sometimes overlook, we don't see the answer properly. So that will be present in the first option. So if you look at M, you miss N. So you see that it is calcium and magnesium and you will tick that answer, then it will be wrong. See, the option D is correct because it is calcium and magnesium, not manganese. So that is why you need to be very cautious in the examination. You need to look at all the options. Without looking at all the, even though you feel that the first option is the answer, don't fix that first option without seeing all the options. I suggest always to go through all the options because maybe 2 options are correct. So 2 options are correct, maybe both 1 and 2 like that may be given in the option. Once if you see all the options, then only you will understand which one is the correct answer. Okay. So next one is question number 14. Question number 14, GATE 2003, 1 mark. GATE 2003, 1 mark question. So the results of the analysis. So somebody has did the quality testing of water and they have evaluated the quality of water and the results are given like this. Turbidity turbidity is 5 mg per liter. 5 mg per liter. Now next is pH is 7.4. pH is 7.4 mg per liter. And next fluorides is 2.5. Fluoride is 2.5 mg per liter. These are all the results of the test report of water. Total hardness is 300 mg per liter. 300 mg per liter. Iron 3.0. Iron 3.0 mg per liter. MPN 50 per 100 ml. MPN 50 numbers per 100 ml. So where the water has failed. See, turbidity limit. What is the turbidity limit? It should not be more than 1 NTU, and in worst case it should not be greater than 10 NTU. So okay, so it is actually 2003 question. In 2003 the limit was 5. In 2003 the limit was 5. In 2012 it was revised. So that is why. So far for 2003 this is okay. It has passed. For 2003 kind of analysis it is passed. Okay. So pH range was 6.5 to 8.5. Okay, it is also passed. Fluoride should be in between 1 to 1.5 mg per liter, but here it is more than that. So here it is failed. It should not be more than 200 mg per liter. Here also it is failed. And it should not be more than 0.3 mg per liter. Here this is also it is failed. It should not be more than, actually it is not at all allowed. So nil is the, so here this is also failed. So what we need to do, what treatments we need to do? We need to give the treatments for rectifying these problems. So here see, option A is turbidity followed by disinfection. Option A is wrong because it is passed in turbidity, no need of treating for turbidity. And the option B is fluorides, okay, and hardness, okay. What about iron and MPN? So that is not complete treatment, it is incomplete treatment. So option B is also not the proper answer. Iron followed by disinfection. So iron and disinfection is also not a complete treatment. It is also only some part of treatment is taken, some part was left. So that is why. So fluorides, hardness, iron followed by disinfection is the right answer. Okay, here what is the treatment we need to give? Fluoride followed by total hardness, followed by iron, and followed by disinfection. So this is the treatments needed for this water. Okay, that is GATE 2003 14th question. Now next is 15th question. See, actually this question 15 we will discuss it in detailed way in miscellaneous water treatment. Okay, miscellaneous water treatment, because here the question is, anyways it is a simple question, we can discuss it here also, but the concept behind this question we will discuss in the miscellaneous water treatments. Okay. So next is question number 15. 2003, 1 mark only. 2003, 1 mark. The question is zero hardness. Zero hardness is achieved. So generally zero hardness achieved means what? Removal of hardness. So removal of hardness we will discuss actually in the topic of water treatment. Here we don't discuss it actually, quality characteristics. So anyways, the question has come, let us discuss. See, generally hardness is removed by various methods. Hardness is removed by lime soda, okay, lime soda method, zeolite method, and demineralization technique. Generally these are the three techniques we use to remove the hardness. Okay, now here generally this demineralization is also called as ion exchange treatment, or we call it as ion exchange. No, it's not ion exchange. So this is ion exchange method. Zeolite method or ion exchange method. Okay, so generally lime soda method will not give you zero hardness, whereas the demineralization as well as zeolite method or ion exchange method, it will give you zero hardness actually. So how it gives zero hardness, why it is the reason and all, we will discuss in the miscellaneous water treatment. So far the zeolite or ion exchange method will give you zero hardness. Even demineralization also give you zero hardness. That is the thing we need to remember up to this point. Okay, so why it is like that, we will discuss it in the miscellaneous water treatment class. Okay, so this is all about the questions up to question number 15 we have did. There are 50 questions present in this topic, so we have 35 questions left. We have to do 35 questions. We will discuss it in the next class. Thank you so much.